For this lab, our goal is to create alum crystals from a saturated alum solution. We created the saturated alum solution by completing 4 different reactions. For the first reaction, we dissolved 1 gram of aluminum foil in 4 molar potassium hydroxide. This reaction is represented by the following chemical equation. As we can see, the solid aluminum foil combined with the hydroxide from the KOH to create aqueous AlOH4-. The potassium from the KOH remained as aqueous K+ ions in the solution, and we can also see that hydrogen gas was produced. Next, we filtered the solution in order to separate any insoluble solid impurities that remained in the aluminum solution using a vacuum filtration method before moving on to reaction 2. Finally, after we did that, for the second reaction, we then took the filtered AlOH4- solution from reaction 1 and slowly added 25 ml of sulfuric acid. This then caused the following reaction to occur. The addition of the sulfuric acid initially caused a white precipitate to form since the aqueous solution AlOH4- converted into a solid AlOH3. However, we saw that as we added more sulfuric acid, a third reaction began. The third reaction, we saw that the additional sulfuric acid neutralized the basic aluminum hydroxide precipitate, and this caused the solid hydroxide to dissolve and form aqueous Al2SO43. This can be represented by the following chemical equation. Then, finally, for the fourth reaction, we cooled the solution by placing it into an ice bath, which led to the following reaction. An ice bath was used to precipitate crystalline alum from the solution. Alum is insoluble at lower temperatures, so when the temperature drops close to freezing, it will fall out of the solution until there is no more alum left in the solution. So then after we collected this solid alum, we washed it with a 50-50 ethanol water mix that we created. We dried it using a vacuum filter suction, and we used this to make the saturated solution we have now in the vial. So to make the solution, we just added 8 grams of alum and 40 ml of water. And then just using regular gravity filtration, we got rid of any remaining impurities that could have been in the solid, and we split it into 3 different vials, 1 for each lab partner. So far it's been less than a week from the time the solution was prepared, and as you can see, there are no crystals yet. The solution looks just like it did when we prepared it in the lab. It is crystal clear, pun intended, but this goes along with the predictions I made in the pre-lab that it would take a couple of months for the crystals to grow. There are probably no crystals yet because not enough water has evaporated and the concentration of the alum is not high enough to cause it to precipitate from the solution. A fun DIY we could do would be to grow our own NaCl crystals with the super easy process by just using table salt and water. All we would need to do is to take the table salt and dissolve it in hot water until we create a saturated solution where no more salt can be dissolved in the water. After the NaCl completely dissolves, we would then place the solution in a container and allow the H2O to evaporate. As the water evaporates, the concentration of the solute, the NaCl, increases, and since NaCl is a solid at room temperature, its solubility permits it to precipitate from the saltwater solution and create crystals. So a different kind of approach, but much more fun, would be to use sugar instead of salt in order to make sugar crystals, which we know as rock candy. Completely edible. I'm not a big fan of rock candy, but this is something you can do following a very similar process to the NaCl crystals. You would just dissolve sugar in boiling water, make a super saturated solution, and then maybe add some food coloring, make it look nice and pretty. Then setting it aside into a glass with wooden sticks. As the water evaporates, there will be less space in the solution for the sugar, and this will lead to the formation of crystals, and then they will form around the stick, so this makes it really easy to consume.